Stand close together, please.
Hi everyone, my name is Keshan and this is...
My name is Brandon.
And this is our soccer robot. And we misspelled project on purpose. For a certain reason. Anyway, so we came from humble beginnings. We started out with amazing Lego pieces, which we didn't know what to do. But once we got them, we did know what to do. These are Mindstorm Lego pieces. And we just started out with that. And here's our dream team. And so, Brandon is missing here, but that's fine. Here's Alex Morgan. She's a professional soccer player. She's amazing. And so, what all of us have in common with Brandon is that our common goal, above all, is to enjoy soccer, and that's why we created this game.
So while building the robot, we used primarily 3 different things. Obviously, the Legos. We all use the Legos. But in order to make a stadium, instead of making a stadium out of Legos, because that would use 20 times as many Legos as there are over there, we use grass turf and we use cardboard box as walls. And our original robot sketch was basically this. We had this as our robot thing with the inputs and the motors coming out of it. This is how we would input it as a controller and how we would actually drive the machine. The flipper was the most challenging mechanical aspect of it because we had to have rotation this way, but that required a motor this way, and that takes up space. And because the way the flipper was set up and how the gears are set up, it takes up a lot of space. And because our field isn't all that big, we wanted to make the most efficient robot as possible.
And so this was our first prototype for the actual robot. And so you can see there are 2 wheels that spins. And it goes forward, backwards, left, right, and the flipper's up there. And so, of course, throughout the whole process, we kept revising and revising, and we ran into problems like these. So we used turf, and so that's not very smooth. So I tried to change up the wheels. These are the different tires I used, and of course I broke the robot to try it on, and so the other robot came to rescue.
And then the second thing we did was having a score counting goal, because it's kind of boring to have mechanically count it yourself and keep track of it, because then you get in arguments. So what we have was a photo gate where whenever the distance changed for the ball and the sensor, the ultrasonic sensor got a different distance, it would add a point to it and play a sound. This is the actual picture of what happened. We have the Mindstorm right here. We have a ultrasonic on this end, and whenever it had a set distance, if that distance was changed, it sends the ball coming in. Small minor problem is that sometimes when the ball was close to one of the sensors, it would actually read a higher number than it's supposed to.
And so originally we wanted to do kind of like a joystick using a Bluetooth kind of method. And so, we'd have the front and the back and all those kind of options that we'd use. And so here's our rough sketch of it. We have the inputs and outputs. So this is our original design. So this one goes left and right. The other one goes front and back, and they have buttons to click to hit the flippers, hit the ball. But unfortunately, Bluetooth isn't really supported by this EV3 kind of model that we use, so we kind of had this scratched idea. And so here's a remote island with fail, and you get remote failure. And so that was the reason why we tried to change up that remote and go for the infrared sensor, which should be on the next slide. And so here you see, this is the receiver, and that's the actual remote. And so depending on what buttons you press, it would send a signal to this receiver, and it would play out the thing. And so here's the remote. So we designed it so it has a very kind of comfy and ergonomic feel to it, and so it's really...
And then our original pseudocode, this is actually almost the exact same code for the robot. What we had was, if the motor, the original joystick code was, if the degrees detected by it was positive and greater than a specific threshold, it would drive forward. If it was less, then it would drive backwards. And with the other motor, it would go in the other direction. But as we all know, the thing didn't really work out because there's no communication between the 2 brains. So we ended up using infrared, which was almost the same thing. If X signal was sent out, do Y. If A signal was sent out, do B. And it was pretty simple and straightforward. Almost exactly followed that. However, there were several limitations. Specifically regarding the photo gate, our cables were just way too short. We tried to make extension cables. We cut a cable in half to try and splice them together. That didn't work too well either. Bluetooth obviously doesn't work. We couldn't link it all into one robot, so we had that kind of problem.
So in this whole process, of course, we had a lot of fun. So Brandon and I had a lot of fun, even though neither of us are in the photo, and even though that's not even our robot, but we all had fun with each other, and it was a great process. Anyway, this is pictures of our robot and the remote. And so throughout this whole process, we learned that the perspective that you look at things and the mindset you have coming into a problem is really crucial. So you see there's different filters and how we kind of go through this, all the same processes to get to this same goal, but yet we go through different pathways. And that's how we build on each other's knowledges, and experiences from the past, and that's how we were able to create something like